The world of today is built on information. That's why maths represent the world. Hello there, and welcome to The Art of Maths, a series where I solve two problems to teach something about a theme revealed at the end of each video. Let's start. Find 5 different natural numbers, so that once each possible pair of numbers is added together, we get the following sums. Pause the video and try to solve the problem. I hope you've managed to solve it, but don't worry if you didn't. What's important is that you tried, for it is very good exercise for your brain. Now let's solve. You may have been tempted to put a system of equations and solve, but you don't know which variables add up to which numbers, so that won't do. First, let's think about how the numbers add up in pairs. We'll label the 5 natural numbers we're looking for, A, B, C, D, E. A gets added with B, then C, D, and E, giving us 4 additions containing A. Same goes for B, C, D, and E. Each of these numbers is getting added 4 times. When counting the addition pairs, we must take into account the repeated ones. We realize there are indeed 10 additions, which is the amount of numbers we were given. One could say they share the same cardinality. When we add all the given sums together, we're basically adding all the possible pairs, meaning each variable we defined will appear 4 times as we previously said. We calculate the sum and factorize the 4. We divide both sides by 4. We have reached the sum of the natural numbers we're looking for. It may seem that we're at a dead end now, but we can use logic to continue. We know that the 5 natural numbers we're looking for are different. Thus we can compare them and find no equality, so we'll define them this way. The reason we're able to do that is because the variables weren't previously defined by any other thing. Now let's take a look at the sums we were previously given. 42 is the greatest one. 14 is the smallest. Thus, 42 is the sum of the 2 greatest numbers, which are A and B. 14 is the sum of the smallest numbers D and E. We can replace here. We solve the equation to get the value of C. We move every constant to the other side without forgetting to change the sign. C is 14. Notice how C is both the 3rd greatest and smallest number at the same time. Adding it to the greatest number A gives the 2nd greatest number. Adding it to E gives the 2nd smallest number, which are 39 and 17, respectively. We replace C, and all that remains is solving basic equations. "25, 17, 14, 11, and 3 are the numbers we're looking for. The reason that this solve works instead of putting a system is because you can only get 4 equations with consistent variables, which were the precise ones I worked with. But you have 5 variables, so you need 5 equations to get each number. That's why we get it by summing everything. This works because of the commutative nature of addition. I hope you like this problem. Let's get to the next one. Alpha, beta, gamma are real numbers, assuming the equalities. Can you find this value? Pause the video and try to solve the problem. I find this problem to be interesting because it's easy actually, but there are so many ways to go wrong with it. To show you what I mean, I'll tell you about how it went when I tried to solve this problem for the first time. At first, when I tried to solve the problem, I noticed that the value we were asked to find was the product of the equal fractions, so it could be written as the cube of one of the equal fractions. But this didn't help. It just complicated the problem, so my initial approach was wrong. I tried to figure out the sum of the equal fractions to equal them with one of the fractions times 3, but it also didn't help. Note that it's extremely important to never just stick with one idea when solving a problem. When it doesn't work, it just doesn't. You mustn't force that idea to be the problem's solution. Instead, you should always be open to learn and change your approach, whether it's in or out of a problem. So I decided to tackle the problem step by step. We can cross-multiply between the fractions. Now we expand. We'll group the alpha terms on one side and the squared terms on the other. We use square difference rule to factorize. We can invert both multiplication factors, and the value doesn't change. We divide both sides by beta minus gamma. All I'm doing is just changing the signs when moving one term to the other side. We can use these and replace them here. That's it. The result is -1. But can you see what's wrong with this problem? The theme of this episode is about information lack and surplus. The thing that is fascinating about the second problem is that there is a surplus in information. You see, the original problem presented us with 3 fractions, but the solution clearly and only involved using 2. This was a purposeful design to make us believe that the problem is more complicated than it actually is. I mean, think about it. The problem presented 3 equalities prompting solvers, such as I and possibly you, to use all of the equalities at the same time and reach a dead end. It's interesting to know that when you solve competition math exams, and probably many other problems, even unrelated to math, you're most likely at an information surplus, regardless of the given problem, since you know too many approaches to solve. And sometimes, only one of them is correct, or at the very least provides an optimal solve. That's why, when solving any problem, it's essential to never stick to just one idea after you're done exploring it and figuring it doesn't work. As of the first problem, it had a very small lack of information that made us define the variables and their ordering on our own. This lack of information can also happen from your side if you don't have enough knowledge. You can even find interesting talks about how an amount of information can affect someone in something as trivial as a game in the way they are designed. And completely outside of problem solving, you're at an information lack or surplus more often than you realize it. For instance, when you research about a specific subject, it could be niche, and you'll probably be at an information lack, so you must know how to acquire that information regardless of it. Other times it's the exact opposite, and there are way too many sources, lies, propaganda, and misinformation, so you must know how to differentiate between truth and lies, or else you'll be at a surplus. What I gave was a very simple example of it, but it actually goes way deeper than that. Anyways, thank you for watching this video. I hope you've learned one thing about problem solving. Take care.